A person can deliver his newspapers in 10 minutes. Their friend can deliver them in 40 minutes along the same route. How long would it take them to deliver the papers if they worked together? One way to set up a working together problem is by using this template. The idea is that if two people are working together to complete a job, both of them are doing a fraction of the job. And when you add those two fractions that each of them is doing, it adds up to 100% of the job, which when you convert that to a decimal is just equal to 1. So we'll set up our equation, which is some fraction of the job plus another fraction of the job is equal to 1. And now let's reread the problem so that we can determine what goes into the numerators and denominators in each of these fractions. The first person can deliver the papers by himself in 10 minutes. So let's designate the first fraction to represent the first person, and so their time alone is going to be 10. For right now, let's just make note of the fact that time is being measured in minutes, and those are the units that we'll use to answer the final question. The friend can deliver the papers in 40 minutes along the same route. So the friend's time alone is going to get a 40 in their denominator. The question says, how long is it going to take them to deliver the papers if they work together? The time that they work together in both fractions should be the same quantity. And since this is the unknown quantity, this is what we're going to assign the x variable to. So we don't know how much time it takes them to work together, and that x is going to go into the numerator of both fractions. Now let's notice that because of the position of the x is in the numerator of the fraction, that this equation is actually a linear equation. However, we can still multiply both sides by the LCD in order to clear the fractions, which will make our computation a little easier. So let's do that first. The LCD in this case is going to be 40. It's the smallest number that both denominators divide evenly into. So we'll multiply both sides of this equation by 40 over 1, and that'll eliminate the fractions in our first step. So we'll start by multiplying 40 over 1 times x over 10, and then add that to 40 over 1 multiplied by x over 40, and then we multiply the LCD on the right-hand side. We actually don't need fractions over there since 1 and 40 are both integers, so we could just go ahead and multiply those two things together, always focusing on keeping our computation as simple as possible. Now it's time to divide these denominators into that LCD. 10 divides into 40 4 times, and 40 divides into 40, leaving just a factor of 1 that remains. So now when we multiply this term together, we've got the 4 and the x that's left, so this product is 4x. And then to that we add this second product, and after we cancel those 40s, the only thing that remains is the x, so we have x here. And then we're equal to 40 on the right-hand side. 4x plus x is 5x, and when we divide both sides by 5, the 5's cancel, and we end up with x is equal to 8. Remember, x represented how long it would take them to deliver the papers together, and our units were measured in minutes, so this is 8 minutes, which means it would take 8 minutes if they worked together.